April 7, 1945, Motoyama Airfield No. 2, Iwo Jima. Brigadier General Ernest Moore's 7th Fighter Command prepares for takeoff as dawn breaks over the volcanic ash. 119 P-51 Mustangs from 3 groups line the coral runway, each carrying 2 massive 165-gallon drop tanks beneath their wings. Today marks the first time American single-engine aircraft will attempt the impossible, a 675-mile journey to escort B-29 Superfortresses all the way to Tokyo and back. In the cockpit of his silver Mustang Duchess, Captain Robert Phillips of the 45th Squadron checks his gauges one final time. The massive external tanks double his plane's weight, making takeoff treacherous on this short runway carved from volcanic rock. But these revolutionary containers will change everything Japanese pilots thought they knew about American capabilities. Tonight, drop tanks, a concept born from American aviation experiments and perfected through wartime necessity, will shock the Japanese High Command when single-engine aircraft appear over the sacred homeland itself. The story begins not on the volcanic beaches of Iwo Jima, but at Selfridge Field, Michigan, on March 5, 1923, where American aviation pioneers first demonstrated the revolutionary potential of external tanks that would transform aerial warfare forever. From that muddy airfield near Detroit to the factories of San Diego, from the drawing boards of Dayton to the coral runways of the Pacific, this is how American ingenuity created the technology that brought war directly to Japan's doorstep. External tank development traces back to Selfridge Field, where Army Air Service engineers faced a fundamental limitation constraining operations. The Boeing MB-3 pursuit planes stationed there could barely reach 400 miles on internal reserves alone, severely limiting their effectiveness against enemies operating from distant bases. Major Henry Hap Arnold, commanding the 1st Pursuit Group, recognized that American air power desperately needed extended range capabilities to match the vast distances future conflicts would demand. The engineering problem seemed mathematically insurmountable. Pursuit planes required speed, maneuverability, and concentrated firepower, TO-5s, characteristics demanding lightweight construction and compact design. Adding substantial internal capacity meant building larger, heavier machines with reduced performance. But Army Air Service engineers at McCook Field in Dayton, Ohio, approached the problem differently. What if planes could carry additional reserves externally during transit phases, then discard the containers when combat performance became paramount? Their experimental solution was elegantly simple yet revolutionary. A 37-gallon aluminum tank would be mounted beneath the plane's centerline, connected to the main system through pressurized lines. Pilots could consume external reserves first during long-range transit, then jettison the empty container before entering combat, requiring maximum performance. This concept allowed aircraft to carry substantial additional reserves without permanent penalties, the Spear achieving optimal balance between range and combat effectiveness. Engineering challenges proved substantially more complex than initial concepts suggested. External containers created significant drag, reducing speed and actually increasing consumption during certain phases. Mounting systems needed sufficient strength to carry heavy loads during violent maneuvering, yet release reliably under extreme combat stress. Transfer mechanisms required sophisticated pressurization systems, maintaining consistent flow during high-G maneuvering and inverted attitudes. Connection fittings demanded perfect sealing, preventing dangerous leaks during extended operations over hostile territory. Army engineers systematically solved these interconnected problems through months of intensive testing and continuous refinement. Tank shapes evolved from simple cylinders to carefully streamlined teardrops, minimizing drag penalties while maximizing internal volume. Quick release mechanisms utilized spring-loaded pylons, ensuring instantaneous separation when pilot-activated switches were engaged during combat emergencies. Systems incorporated engine-driven vacuum pumps, forcing external reserves into internal wing tanks under positive pressure, regardless of aircraft attitude. Every component underwent rigorous testing, ensuring absolute reliability under extreme operational conditions. Tanks were subjected to vibration testing, simulating thousands of hours, temperature cycling from Arctic cold to desert heat, and pressure testing exceeding maximum operational loads. Release mechanisms endured continuous activation cycles while subjected to combat-level G forces. System components required precision manufacturing tolerances, preventing contamination or flow disruption that could cause catastrophic engine problems during critical mission phases. On March 5, 1923, several Boeing MB-3 aircraft took off from Selfridge Field carrying these revolutionary experimental containers, marking a pivotal moment that would ultimately transform global military strategy. The test mission represented far more than simple engineering evaluation, MAR. It marked the birth of technology that would fundamentally alter tactical and strategic possibilities of aerial warfare throughout the 20th century. Beyond, the planes achieved a remarkable 400-mile operational radius during the test flight, exactly double their normal range capability on internal reserves alone. This historic achievement established the first successful operational use of jetisionable containers in American military aviation, creating engineering precedents and operational procedures that would evolve into sophisticated systems used during World War II's massive aerial campaigns across multiple theaters. The immediate success at Selfridge Field clearly demonstrated the technology's tremendous potential for revolutionizing military aviation, but further development remained severely limited throughout the challenging interwar period. Restrictive military budgets constrained experimental programs, while prevailing isolationist policies minimized emphasis on long-range operations. However, several forward-thinking officers, including future Lieutenant General James Doolittle, recognized that future global conflicts would inevitably demand extended-range capabilities, far exceeding current limitations. During the late 1930s, international tensions escalated dramatically as aggressive totalitarian regimes expanded territorial control through military conquest. Ongoing European conflicts clearly demonstrated that short-range defensive aircraft proved tactically vulnerable to enemies who could simply wait until limitations forced defensive planes to withdraw. American military planners studying these emerging lessons recognized that future conflicts would absolutely demand aircraft capable of escorting bomber formations across vast oceanic distances previously considered operationally impossible. The Spanish Civil War provided particularly valuable lessons about extended-range operations. German and Italian planes operating from secure bases could attack Spanish Republican forces, then withdraw when defensive aircraft appeared, knowing limitations would force defenders to return within hours. This tactical pattern would be repeated extensively during early World War II operations, until technological solutions eliminated the fundamental range limitations constraining defensive operations. In 1938, the expanding Army Air Corps commissioned comprehensive development programs at multiple major industrial facilities nationwide. The Consolidated Aircraft Corporation in San Diego, California, examined various external storage concepts with intensive engineering focus and substantial investment. The Republic Aviation Corporation in Farmingdale, New York, joined these efforts, followed by North American Aviation in Inglewood, California. These premier manufacturers would systematically transform experimental technology into reliable, mass-produced systems capable of equipping thousands of American planes operating across global theaters. American engineers developed increasingly sophisticated external systems throughout the late 1930s and early 40s, incorporating lessons learned from European combat operations and extensive domestic testing programs. Standard operational configurations included 75-gallon wing-mounted containers weighing approximately 300 pounds when completely filled, plus significantly larger 165-gallon centerline belly tanks, adding over 1,000 pounds to total aircraft gross weight. Advanced production models featured sophisticated pressurization systems, accurate quantity indicators, and reliable emergency jettison capabilities, enabling safe operations under all conceivable combat conditions. The advanced technology emerging from American industrial facilities represented elegant engineering solutions to extraordinarily complex operational requirements spanning multiple technical disciplines. Containers ranged from relatively small wing-mounted units providing modest range extensions for tactical operations to massive centerline belly tanks nearly doubling operational radius for strategic escort missions. Quick-release mechanisms evolved from simple mechanical systems activated by cable controls to sophisticated pneumatic devices, ensuring absolutely reliable separation under extreme combat stress and high-G maneuvering loads. Transfer technology advanced dramatically from primitive gravity-fed systems dependent on aircraft attitude to sophisticated pressurized configurations, maintaining consistent flow rates during violent aerial maneuvering, inverted flight, and extended high-G combat situations. Electrical systems provided accurate quantity information to cockpit instrumentation through calibrated sensors and reliable wiring. Internal baffles prevented dangerous sloshing that could destabilize flight characteristics during critical combat phases, when pilot attention was focused entirely on enemy threats. Tank construction methodology utilized multiple specialized manufacturing approaches, specifically optimized for different operational requirements and strategic material availability. Traditional aluminum alloy tanks provided maximum durability and reusability, but required strategic materials desperately needed elsewhere in expanding wartime production programs. British-developed paper containers, constructed from specially treated resin-impregnated craft paper, offered lightweight single-use alternatives that conserved precious metals for essential military applications while maintaining adequate performance. American engineers simultaneously perfected pressed steel designs that balanced efficient manufacturing processes with operational reliability under harsh combat conditions. These steel tanks could be mass-produced using existing automotive industry infrastructure and tooling, dramatically reducing production costs while maintaining performance standards adequate for combat operations. The manufacturing flexibility provided by multiple construction methods ensured continuous production regardless of strategic material shortages or enemy action against specific industrial facilities. Each complete external system contained numerous sophisticated internal components, invisible to casual observation, but absolutely critical for reliable operation. Pressurization lines connected directly to aircraft engine-driven vacuum pumps, forcing reserves from external containers to main systems under carefully regulated positive pressure regardless of aircraft attitude. Electrical connections provided continuous quantity information to cockpit gauges through precisely calibrated sensors and shielded wiring designed to function reliably despite combat damage and electromagnetic interference. Internal baffle systems prevented dangerous sloshing during high-G combat maneuvering that could dramatically affect aircraft center of gravity and stability characteristics. Emergency dumping systems enabled rapid weight reduction when immediate performance improvement became absolutely critical for combat survival or emergency landing situations. System filters prevented contamination from reaching sensitive engine components, while line heaters prevented ice crystal formation during high-altitude operations in extreme weather conditions. Manufacturing specifications demanded incredibly precise tolerances and quality control standards exceeding those required for many primary aircraft structural components. Lines required absolutely perfect sealing, preventing hazardous leaks that could ignite during combat operations, creating catastrophic hazards for aircraft and pilots. Release mechanisms demanded completely reliable activation under extreme stress conditions, while simultaneously withstanding continuous vibration and structural loads during extended operations lasting up to 8 hours. Tank aerodynamic characteristics required extremely careful design optimization, minimizing drag penalties that significantly reduced performance and increased consumption. Quality control procedures exceeded peacetime commercial aviation standards, recognizing that system problems during extended overwater operations could prove immediately catastrophic for single-engine pilots, operating hundreds of miles from friendly territory with no possibility of rescue or emergency landing. By 1941, American industrial facilities were producing external tanks in unprecedented quantities, as military planners recognized the strategic importance of extended-range operations. The surprise attack on Pearl Harbor dramatically accelerated production schedules as Pacific theater requirements became immediately apparent. Factories that had previously manufactured several thousand tanks annually suddenly confronted military orders, demanding tens of thousands monthly to equip rapidly expanding units deploying across global theaters. The American industrial response proved truly remarkable, demonstrating the nation's extraordinary manufacturing capacity and technological flexibility. American manufacturers not only successfully met these dramatically increased production demands, but consistently exceeded them through innovative mass production techniques, expanded manufacturing facilities, and systematic workforce training programs. Factory workers who had never previously worked on military equipment quickly mastered sophisticated manufacturing processes, ensuring consistent quality while achieving unprecedented production rates. Specialized production facilities operated continuously throughout the war years, with multiple shifts maintaining 24-hour manufacturing schedules. Quality control procedures ensured every tank met stringent military specifications, regardless of production pressures or material shortages. Advanced manufacturing techniques developed during wartime production would later influence post-war aviation industry practices and contribute significantly to American commercial aviation leadership during the following decades. American squadrons completely reorganized their operational structures to accommodate extended-range missions, requiring sophisticated management procedures and specialized maintenance support. Initially, tank maintenance responsibilities were assigned to existing squadron ground crews, but rapidly expanding operational demands soon required dedicated technicians within each maintenance organization. By June 1944, the Army Air Forces had established specialized systems specialists throughout units operating across European, Mediterranean, Pacific, and China-Burma-India theaters worldwide. Squadron organizational structures evolved dramatically to support extraordinarily complex long-range missions requiring mathematical precision in consumption, planning, and monitoring. Each P-51 squadron typically organized 24 operational aircraft into 3 8-plane flights specifically optimized for extended escort operations, requiring continuous formation integrity over vast oceanic distances. Mission planning staffs calculated detailed requirements, accounting for takeoff weight penalties, varying cruise power settings at different altitudes and atmospheric conditions, and substantial emergency reserve requirements, ensuring safe return to base under adverse weather conditions or unexpected combat damage scenarios. Pre-flight preparation procedures became elaborate multi-hour sequences, ensuring mission success through systematic attention to every critical detail. Specialized ground crews filled external tanks immediately before engine start procedures to minimize contamination from extended storage periods that could damage sensitive engine components or reduce quality. Pilots verified tank pressurization systems during comprehensive engine run-up procedures, methodically checking every gauge, indicator, and system component before committing to extended overwater operations. Formation leaders calculated precise consumption rates for varying altitudes and power settings based on detailed weather forecasts and anticipated tactical conditions throughout the planned mission profile. Comprehensive weather briefings emphasized wind conditions that could dramatically affect requirements during 8-hour combat missions, covering vast oceanic distances with minimal navigation aids and no possibility of emergency. Landing between departure and destination points. Navigator bombardiers aboard lead aircraft carried detailed consumption charts and backup navigation equipment, enabling precise position fixes and course corrections throughout extended missions. Radio operators maintained continuous communication schedules with base weather stations and rescue coordination centers, providing regular position reports and status updates that could trigger emergency rescue operations if aircraft failed to return as scheduled. Pilot training programs expanded substantially to address operational peculiarities, requiring entirely new techniques and emergency procedures. Aviators systematically learned to manage significantly altered aircraft handling characteristics with partially filled external tanks, where sloshing during formation flying and combat maneuvering created unpredictable behavior that could prove dangerous or fatal without proper training and experience. Advanced instrument flying procedures emphasized continuous quantity monitoring across multiple tank systems, preventing starvation during critical mission phases when pilot attention was focused on navigation, formation flying, or combat situations. Comprehensive emergency protocols covered tank jettisoning procedures during engine problems, unexpected combat encounters, severe weather situations requiring immediate weight reduction, and various system malfunctions that could threaten mission success or pilot survival. Formation flying techniques required substantial modification to accommodate heavily loaded aircraft with significantly different performance characteristics compared to standard configurations. Traditional formations assumed similar aircraft capabilities across all formation members, but tank-equipped planes demonstrated longer takeoff run requirements, slower initial climb rates, and modified power settings necessary to maintain formation integrity during extended operations, lasting up to 8 hours over hostile territory. Experienced flight leaders developed entirely new tactical procedures, accommodating varying loads as external tanks emptied at different rates throughout extended missions. Individual aircraft performance gradually improved as external reserves were consumed, requiring continuous formation adjustments and power setting modifications. Radio communication procedures included standardized status reporting, enabling formation leaders to coordinate synchronized tank jettisoning when combat situations demanded maximum aircraft performance. The operational complexity of management became immediately apparent during realistic training exercises conducted prior to combat deployment. Pilots simultaneously monitored internal wing tank levels, external container quantities, transfer rates between systems, engine parameters, navigation information, formation positions, radio communications, and weather conditions, while remaining constantly alert for enemy aircraft or other threats requiring immediate defensive action. Emergency procedures addressed system problems, partial tank separation situations, combat damage affecting transfer systems, and various mechanical problems that could occur during extended overwater operations. Pilots practiced transfer procedures under simulated emergency conditions, learning to maintain aircraft control while manipulating system controls during high-stress situations that could determine survival outcomes. This comprehensive organizational transformation systematically prepared American units for combat operations, substantially exceeding anything previously attempted in military aviation history. Advanced technological capabilities existed through innovative industrial development. Intensive training programs had established operational proficiency through systematic preparation and realistic practice, and sophisticated logistical systems supported sustained extended-range operations through careful planning and comprehensive support organization. All essential elements awaited the ultimate operational test, prize, protecting American heavy bomber formations during daylight precision bombing attacks against heavily defended Japanese industrial and military targets located deep within enemy territory. The strategic and tactical success of these revolutionary operations would validate years of technological development, training, preparation, and organizational restructuring, while potentially determining the outcome of the Pacific Theater campaign. The strategic military situation during early 1945 demanded exactly these extended-range escort capabilities for successful prosecution of the strategic bombing campaign against Japan. American B-29 Superfortresses, based in the recently captured Mariana Islands, possessed sufficient range and payload capacity to reach critical Japanese industrial targets, but previous unescorted bombing missions had suffered devastating losses to determined Japanese interceptors approaching unsustainable casualty rates, threatening the entire strategic bombing program. Earlier bombing raids had experienced aircraft losses approaching 20% of participating formations, ASC, casualty rates that could not be sustained indefinitely without completely undermining strategic bombing. Effectiveness. Japanese pilots, though increasingly inexperienced due to training limitations and veteran pilot losses, could still inflict severe damage on unescorted American bomber formations through coordinated attacks, utilizing superior numbers, intimate knowledge of local geography, and desperate courage, born from defending their homeland against foreign invasion. General Curtis LeMay, commanding the 21st Bomber Command responsible for B-29 operations against Japan, clearly recognized that comprehensive escort would completely revolutionize strategic bombing effectiveness while dramatically reducing unsustainable bomber crew casualties. Japanese tactics typically involved waiting patiently until American escorts were forced to turn back due to limitations, then launching coordinated mass attacks against vulnerable bomber formations during the most critical phases of bombing missions, when aircraft were constrained by bombing run requirements and unable to take effective evasive action. Extended-range escort capability would completely eliminate this fundamental Japanese tactical advantage, while forcing Japanese aircraft to engage superior American planes under conditions heavily favoring Allied aircraft performance, characteristics, and superior pilot training standards. American pilots possessed extensive combat experience, superior aircraft, and tactical doctrines proven effective during successful European theater operations against equally determined German opposition. The successful capture of Iwo Jima during February and March 1945 provided the essential forward airbase infrastructure necessary for practical long-range escort operations against Japanese targets. Located approximately 675 miles southeast of Tokyo, This strategically vital volcanic island placed North American P-51 Mustangs within theoretical maximum escort range of critical Japanese industrial and military targets throughout the southern portions of the main Japanese islands. However, theoretical maximum range represented engineering calculations assuming absolutely perfect operational conditions, no combat maneuvering, optimal weather throughout the mission, precise navigation without course deviations, and consumption figures exactly matching theoretical engineering specifications under controlled test conditions. Realistic combat operations demanded substantial additional safety margins, accounting for weather delays, navigation errors, combat maneuvering, and emergency situations that only external containers could reliably provide under actual operational conditions. Iwo Jima itself presented numerous unique operational challenges that complicated operations despite its strategic value. The island's 3 existing airfields had been literally carved from volcanic ash and coral debris, creating enormous dust clouds during takeoff and landing operations that reduced visibility and created maintenance problems for sensitive aircraft engines and equipment. Frequent high winds from Pacific weather systems complicated operations, while severely limited island space restricted aircraft parking areas and maintenance facility construction. Maintenance ground crews worked under extremely primitive conditions, maintaining sophisticated aircraft with minimal shelter protection and basic tool availability. Despite these substantial operational hardships, dedicated American military personnel successfully transformed Iwo Jima into a major advanced base, supporting hundreds of daily combat sorties against Japanese targets throughout the remaining months of Pacific Theater operations. The 7 Fighter Command, under the operational leadership of Brigadier General Ernest Moore, established comprehensive operational headquarters facilities on Iwo Jima during March 1945. General Moore, an experienced pilot and proven tactical leader, understood the extraordinary challenges of extended-range operations better than most senior military officers due to his extensive Pacific Theater combat experience and pre-war involvement with long-range aviation development programs. Moore's specialized planning staff systematically developed detailed operational procedures for very long-range bomber escort missions, including precise consumption calculations for varying weather and tactical conditions, optimal weather routing procedures, minimizing consumption while avoiding severe weather systems, comprehensive emergency procedures for aircraft mechanical problems or combat damage, and elaborate rescue coordination arrangements for aircraft and crews forced down during extended overwater operations between Iwo Jima and Japanese territory. 3 complete groups would conduct combat operations from Iwo Jima's limited airfield facilities, the veteran 15th Group arriving in February, the experienced 21st Group deploying in March, and the newly formed 506th Group reaching the island in May 1945. Each group brought over 100 advanced P-51 Mustang aircraft, plus comprehensive support personnel, creating a formidable combined force capable of providing continuous escort protection for large B-29 bomber formations throughout their complete mission profiles to Japanese targets and return to Mariana Islands bases. The 15th Group, consisting of the 45th, 47th, and 78th Squadrons, had extensive combat experience and proven effectiveness in previous Pacific Theater operations. The 21st Group, including the 46th, 72nd, and 531st Squadrons, brought valuable Southwest Pacific combat experience despite limited P-51 transition training time. The 506th Group, composed of the 457th, 458th, and 462nd Squadrons, represented the most recently formed unit, but possessed the most extensive P-51 training and preparation, specifically focused on very long-range escort operations. On April 7, 1945, at precisely 04:45 hours local time, Captain Robert Phillips of the 45th Squadron advanced throttles on his powerful Packard Merlin engine and began his takeoff roll from Motoyama Airfield No. 2. His carefully maintained P-51 Mustang Duchess carried maximum external loading, 2 165-gallon containers mounted beneath his wings, plus an additional 85-gallon tank, installed behind his armored cockpit seat. The massive external load added over 1 full ton to his aircraft's normal combat weight, making takeoff extremely precarious on the relatively short coral runway with minimal safety margins for pilot error or mechanical problems. Phillips had trained extensively for this historically significant mission through months of intensive preparation, but realistic training exercises could never completely replicate every aspect of actual extended-range combat operations under enemy action over hostile territory. The heavily loaded Mustang required nearly the complete runway length for safe takeoff, finally achieving flying speed and lifting off with absolutely minimal safety margin for any mechanical problems or pilot errors. Behind Phillips, 67 additional heavily loaded Mustangs from all three groups struggled into the humid morning air, their pilots fighting unusually heavy controls and significantly reduced climb performance while maintaining precise formation, discipline essential for accurate navigation and mutual protection during the long flight ahead. The complete formation climbed slowly to predetermined cruising altitude, each individual pilot carefully monitoring critical engine temperature gauges and flow rate indicators throughout the extended climb phase. External containers created substantial additional aerodynamic drag, significantly increasing consumption during the climb to cruising altitude when engines operated at high power settings. Mission planning staffs had calculated these performance penalties with mathematical precision, but individual aircraft performance characteristics varied slightly due to manufacturing tolerances, maintenance conditions, and minor equipment variations that could affect overall mission success. Experienced pilots continuously adjusted individual engine power settings to maintain precise formation positions while simultaneously maximizing efficiency during the critically important long flight phase ahead. Formation integrity was absolutely essential for successful navigation over vast oceanic distances, with minimal electronic navigation aids and no reliable landmarks visible from normal cruising altitudes. Navigation procedures required extraordinary precision throughout the entire mission profile. The complete 675-mile route from Iwo Jima to Tokyo was entirely over open ocean waters, with virtually no distinctive landmarks visible from standard cruising altitudes that could provide position verification or course correction information. Limited-range radio navigation beacons provided some directional guidance, but Japanese electronic warfare efforts could disrupt or jam electronic navigation aids at critical moments. Dead reckoning navigation using magnetic compass headings and carefully estimated wind corrections remained the primary navigation method available to pilots, demanding continuous position, plotting, and frequent course corrections throughout the extended flight based on wind observations and estimated ground speed calculations. Navigation errors could prove fatal for single-engine aircraft operating at maximum range over hostile waters with no emergency landing possibilities. Weather conditions posed constant operational challenges throughout extended overwater flights. Pacific weather systems could change rapidly and unpredictably, forcing formation leaders to make difficult tactical decisions about route modifications, altitude changes, or complete mission continuation based on incomplete weather information and limited communication with base weather stations. Headwind conditions significantly increased consumption and could threaten mission completion or safe return to base, while favorable tailwind conditions provided welcome assistance, reducing burn rates. Extensive cloud cover could seriously complicate navigation procedures while simultaneously offering valuable concealment from Japanese radar detection systems. Severe storm systems required substantial course deviations that consumed precious reserves absolutely essential for the return flight to Iwo Jima. The primary strategic target for this historic first very long-range escort mission was the critically important Nakajima Aircraft Company's Musashino engine manufacturing plant located in Tokyo, where experienced Japanese engineers and technicians produced advanced aircraft engines for their remaining operational aircraft. General LeMay's target selection represented sophisticated strategic planning. 9. Systematically destroying aircraft engine production facilities would effectively cripple remaining Japanese air power capabilities more efficiently than attacking individual airfields or completed aircraft manufacturing facilities. 112 powerful B-29 Superfortresses from the veteran 73rd Bombardment Wing would conduct the precision daylight bombing attack against this strategically vital industrial target. The massive four-engine bombers carried substantial bomb loads, specifically designed to destroy precision manufacturing equipment and specialized production facilities that could not be easily replaced under wartime conditions with limited raw materials and increasingly scarce technical expertise. Japanese radar operators stationed at Choshi Early Warning Station detected unusual aircraft formations approaching from the southeastern direction at approximately 0900 hours Tokyo time. Initial radar contact signatures appeared generally consistent with previous B-29 bomber formations that had conducted numerous attacks against Japanese targets during recent months, but additional smaller radar contacts clearly accompanied the main bomber formation throughout their approach flight. These mysterious smaller contacts should have turned back toward their bases hours earlier due to well-understood capacity limitations. No known single-engine aircraft possessed sufficient internal capacity to escort heavy pursuit bombers from any American bases to Tokyo and return safely. Experienced Japanese radar operators immediately reported these anomalous and potentially significant contacts to regional air defense headquarters, but senior Japanese officers initially dismissed these reports as probable equipment malfunctions or observer misidentification of bomber formation elements. Japanese pilots from the elite 302nd Naval Air Group, one of Japan's most experienced and successful combat units with over 70 confirmed aerial combat victories against Allied aircraft, received urgent scramble orders at Atsugi Naval Air Station, located southwest of Tokyo. This formidable combat unit maintained 18 of Japan's finest Kawanishi Non-KJ George interceptor aircraft, specifically configured and positioned to intercept American heavy bomber formations approaching the critically important Tokyo metropolitan region. Comprehensive intelligence briefings provided to Japanese units had never mentioned any possibility of American single-engine aircraft, providing continuous escort protection throughout complete mission profiles, reaching Japanese homeland targets. Japanese tactical planning and defensive preparations were based entirely on the fundamental assumption that American escorts would be forced to abandon bomber formations due to limitations well before reaching Japanese territory, leaving bombers vulnerable to coordinated Japanese attacks during the most critical bombing phases. The experienced Japanese formation climbed rapidly to optimal intercepting altitude of 28,000 feet as American aircraft swept in protective formations ahead of the approaching heavy bomber stream. Through their aircraft canopies, veteran Japanese pilots observed something that Japanese military planners had previously considered tactically and technically impossible: dozens of North American P-51 Mustang aircraft flying in perfect operational formation directly over Tokyo itself. The Americans had achieved what senior Japanese military leaders considered physically impossible, given known aircraft capacity limitations and operational range restrictions, successfully bringing single-engine aircraft across 675 miles of open ocean to provide comprehensive protective escort coverage during bombing attacks against the Japanese homeland. This tactical achievement represented a fundamental shift in strategic bombing capabilities that would affect all future defensive planning and operations. The immediate psychological impact on experienced Japanese pilots proved profoundly demoralizing and tactically disruptive. For over 3 years of Pacific Theater combat operations, Japanese pilots had consistently enjoyed the significant tactical advantage of interior defensive lines, routinely attacking American bomber formations only after escorting aircraft had been forced to depart due to capacity limitations and range restrictions. This fundamental tactical advantage, which had formed the basis of all Japanese defensive planning and pilot training programs, had suddenly and completely disappeared without warning. American escort aircraft could now accompany heavy bomber formations throughout their entire mission profiles, engaging Japanese interceptor aircraft under tactical conditions, heavily favoring superior Allied aircraft performance characteristics and more extensive pilot training standards developed through years of intensive combat experience. First aerial combat engagement commenced at precisely 0955 hours, when Japanese interceptors initiated attack procedures against the American escort formation. Captain Phillips immediately activated his external tank jettisoning systems upon visual contact with approaching Japanese aircraft, instantly transforming his heavily loaded long-range escort aircraft into a highly maneuverable air superiority plane, with performance characteristics superior to any operational aircraft that Japan could deploy against American formations. The discarded containers, having successfully served their essential purpose during the extended transit flight, tumbled toward Tokyo Bay far below, while Phillips rapidly maneuvered his suddenly responsive and significantly lighter aircraft against the surprised and tactically unprepared Japanese veteran pilot. The complete transformation from heavily loaded escort configuration to maximum performance air superiority aircraft occurred almost instantaneously, providing American pilots with decisive tactical advantages during the subsequent combat engagement. The sophisticated tank jettisoning process represented the successful culmination of years of intensive engineering development and extensive testing procedures. Pneumatic release systems activated by cockpit-mounted pilot switches separated heavy containers cleanly from aircraft mounting pylons within several seconds of activation. Advanced line systems incorporated reliable, quick disconnect fittings that prevented spillage or system contamination during emergency separation procedures. The dramatic transformation from heavily loaded escort to high-performance air superiority combat aircraft occurred virtually instantaneously, providing American pilots with overwhelming tactical advantages during critical combat engagement phases. The intense aerial engagement lasted 28 minutes of continuous combat maneuvering over the Japanese capital city. American P-51 Mustang aircraft, completely freed from their external system burdens and weight penalties, demonstrated overwhelming performance advantages against every type of Japanese aircraft encountered during the engagement. Experienced American pilots claimed 15 confirmed aerial victories, while losing only 3 aircraft to combined enemy action and anti-aircraft ground fire from Japanese defensive positions. More strategically significant than individual combat effectiveness statistics, the escorted B-29 bomber formation successfully completed precision bombing runs against their assigned target with minimal interference from Japanese defensive aircraft, achieving destruction levels protected by aircraft that theoretically should not have existed over Tokyo, according to every previous Japanese tactical assumption and defensive planning scenario. Individual combat actions throughout the engagement clearly demonstrated the remarkable effectiveness of both superior American aircraft technology and intensive pilot training programs. First Lieutenant James Crawford of the 21st Group courageously engaged 4 Japanese aircraft simultaneously, skillfully utilizing superior P-51 performance characteristics and proven tactical training procedures to destroy 2 enemy aircraft while successfully driving off the remaining attackers without sustaining combat damage. Technical Sergeant William Harrison, an experienced combat veteran of extensive European theater operations, successfully applied hard-learned tactical lessons from aerial combat over Germany to Pacific theater engagement conditions, systematically engaging Japanese aircraft using proven energy management tactics that consistently maximized inherent American aircraft performance advantages while minimizing exposure to enemy defensive capabilities. Japanese ground defense controllers struggled desperately to comprehend the unprecedented tactical situation rapidly developing over their defended homeland territory. Monitored radio communications revealed widespread confusion and complete disbelief, as experienced Japanese pilots reported impossible American single-engine aircraft presence operating over Tokyo at combat effectiveness levels that contradicted every established tactical assumption and defensive planning premise. Flight Petty Officer Saburo Sakai, Japan's second-ranking ace with over 60 confirmed combat victories against Allied aircraft throughout the Pacific theater, later described the initial appearance of long-range American escort aircraft over Japanese territory as the precise moment when experienced Japanese pilots realized that conventional air defense concepts and tactical doctrines had become completely and irreversibly obsolete. The broader strategic implications of this successful mission extended far beyond immediate individual combat effectiveness measurements or bombing accuracy statistics. American aircraft had conclusively demonstrated that no significant target within the complete Japanese archipelago remained beyond the effective reach of escorted heavy bomber formations operating from advanced Pacific theater bases. The revolutionary external tank technology enabling such extended-range escort operations represented far more than impressive technological achievement, ISAA. It embodied American industrial manufacturing capacity successfully, translated into decisive strategic air superiority that Japanese military forces could never hope to match through conventional defensive measures alone. Japanese military leadership immediately recognized that the fundamental strategic balance of Pacific theater aerial warfare had shifted completely and permanently. All previous Japanese defensive planning had necessarily assumed that American heavy bomber formations would remain tactically vulnerable during critical approach and departure mission phases, when operating without effective escort as protection due to range limitations. This basic tactical assumption had justified dispersing limited Japanese units across multiple airfield locations rather than concentrating maximum available defensive strength against individual bombing raids. The sudden introduction of reliable extended-range American escort capability rendered this entire defensive strategy completely obsolete overnight, forcing Japanese military planners to completely reconsider fundamental defensive concepts while lacking sufficient resources, industrial capacity, or remaining time to implement effective alternative defensive measures. The strategic initiative had shifted permanently to American forces possessing technological and industrial advantages that Japanese forces could not match. The remarkable success achieved during the April 7th mission established comprehensive operational patterns and tactical procedures that would be systematically replicated across the entire Pacific theater throughout the remaining months of active warfare. On April 12th, 72 P-51 Mustang aircraft successfully escorted 116 B-29 Superfortress bombers, attacking Kawasaki Aircraft Company manufacturing facilities in Akashi. This follow-up mission clearly demonstrated that the April 7th success represented no temporary anomaly, MC. American aircraft could now routinely escort heavy bomber formations to virtually any target located within Japanese island chain. Technical Sergeant Michael Kowalski of the 458th Squadron encountered a potentially fatal emergency situation during the Akashi escort mission when his aircraft's primary system developed a serious leak, somewhere over the Pacific Ocean during the return flight phase. Engine-driven pumps began drawing air instead of aviation reserves, creating an immediate threat of complete engine problems, hundreds of miles from the nearest friendly airfield, with no possibility of emergency landing or rescue operations. His tactical situation initially appeared completely hopeless. Total engine problems over the Pacific Ocean meant virtually certain death for single-engine pilots operating at absolute maximum range with no emergency landing, alternatives, and minimal rescue capabilities. However, Sergeant Kowalski's extensive specialized training in external system management procedures and emergency cross-feed operations proved absolutely decisive for his ultimate survival under these extreme circumstances. He successfully executed emergency transfer procedures from his undamaged containers to internal wing tanks, using backup cross-feed systems, specifically designed and installed for exactly these types of critical emergency situations. The complex emergency procedure required precise timing, coordination, and steady manual control, while maintaining formation flight discipline over open ocean, but Kowalski successfully maintained engine operation throughout the complete 3-hour return flight to Iwo Jima. His successful emergency procedures clearly demonstrated how sophisticated external systems provided essential operational redundancy and emergency capabilities that could enable aircraft and pilot survival in situations that would inevitably prove fatal when relying solely on internal storage systems without backup alternatives. This incident validated years of engineering development focused on reliability and redundancy for extended overwater operations. Lieutenant Colonel James Tapp discovered an entirely unexpected tactical application for external systems during escort missions over Osaka on April 28. When determined Japanese aircraft attempted carefully coordinated mass attacks against his assigned bomber formation from below, Tapp immediately ordered his complete Mustang squadron to jettison their partially filled containers directly onto the attacking enemy aircraft formations below. The falling containers, each weighing several hundred pounds when partially filled with remaining reserves, effectively disrupted Japanese attack formations, while simultaneously providing American pilots with crucial tactical advantages during the subsequent aerial combat engagement. The innovative tactic proved immediately effective in breaking up coordinated enemy attacks that might otherwise have successfully penetrated bomber defensive formations. This combat incident revealed completely unexpected tactical applications for external technology, extending far beyond simple range enhancement for escort operations. External containers could serve effectively as improvised aerial weapons when tactically jettisoned over enemy aircraft formations during specific combat situations. The significant psychological effect proved equally valuable. Japanese pilots breaking off critical attack runs to avoid falling debris provided American bomber formations with additional protective coverage beyond conventional escort tactics and procedures. American pilots quickly incorporated this innovative technique into standard tactical procedures when combat circumstances permitted its safe and effective employment. Training programs were modified to include instruction in tactical jettisoning procedures, and formation leaders received guidance on optimal timing and positioning for maximum effectiveness against enemy aircraft formations. Marine Captain Eugene Patterson experienced external technology's life-saving potential during extended combat service with Marine Squadron 214, operating from recently captured Kadena Airfield on Okinawa. Patterson's specialized Marine unit conducted regular extended-range sweeps over Kyushu, actively seeking Japanese aircraft being held in strategic reserve for planned kamikaze attacks against American invasion shipping concentrated around Okinawan waters during the ongoing ground combat operations. During a critical mission over Kanoya Airfield on May 15th, Patterson's flight encountered 12 Japanese aircraft attempting to escape to alternate airfield locations rather than engaging American aircraft in direct aerial combat. The American aircraft had already been airborne for over 4 hours, with supplies rapidly approaching critically low levels that would normally require immediate return to base to prevent exhaustion emergencies. However, Captain Patterson's external containers provided sufficient additional reserves to enable continued pursuit and successful engagement operations, ultimately resulting in the destruction of 8 Japanese aircraft that would otherwise have survived to participate in subsequent kamikaze operations against American naval forces supporting the Okinawa invasion campaign. The tactical significance of this particular engagement extended substantially beyond immediate combat effectiveness measurements. Japanese air commanders had systematically adopted defensive strategies based primarily on avoiding direct combat engagement with superior American aircraft, instead carefully preserving remaining aircraft and experienced pilots for strategically planned kamikaze operations against American invasion shipping concentrated around recently captured Pacific islands. These conservative Japanese tactics were based on the reasonable assumption that American aircraft operating at maximum operational range would necessarily lack sufficient reserves for extended combat operations or pursuit missions against fleeing enemy aircraft. Revolutionary external tank technology rendered these tactical assumptions completely invalid, enabling American aircraft to engage Japanese aircraft throughout their complete extended operational radius without capacity constraints. These diverse tactical applications clearly illustrated why external systems rapidly earned recognition as genuine force multipliers among American combat units operating throughout the Pacific theater. Unit commanders could now deploy escort formations to solve specific tactical problems that conventional shorter-range aircraft simply could not address effectively under any circumstances. The technology's remarkable operational flexibility enabled mission planning staffs to respond rapidly and effectively to changing tactical intelligence while maintaining continuous protective coverage for vulnerable bomber formations throughout extended combat operations. Staff Sergeant Bobby Henderson, serving with the 462nd Squadron, directly experienced the technology's remarkable versatility during a dangerous rescue mission conducted in June. A B-29 bomber crew had been located on a small, uninhabited island northeast of Tokyo after successfully bailing out from their severely damaged aircraft, but available rescue aircraft lacked sufficient operational range to reach the isolated location from conventional base facilities. Henderson's specially configured flight, equipped with maximum external loading, successfully provided essential combat air patrol coverage during the extremely hazardous rescue operation conducted deep within Japanese-controlled territory. The extended loiter capability enabled by containers permitted continuous protective coverage until rescue aircraft successfully extracted the complete bomber crew without casualties or capture by Japanese forces. Chinese nationalist pilot Colonel Wei Ming discovered additional practical applications while operating American P-51 Mustang aircraft against Japanese military positions in Manchuria during spring operations. When conventional aviation supplies became completely unavailable due to effective Japanese interdiction efforts against supply lines, Wei's squadron successfully utilized captured Japanese aviation reserves in American-manufactured containers, effectively extending operational capability despite severe logistical challenges imposed by enemy military operations. The remarkable system compatibility demonstrated exceptional engineering foresight in original tank design specifications and manufacturing standards. American systems could successfully utilize various types and grades, providing operational flexibility that proved invaluable under challenging combat conditions, where standard supply procedures might be disrupted or completely unavailable. These diverse operational examples comprehensively revealed the extraordinary impact of external technology on Pacific theater, air operations extending far beyond simple range enhancement capabilities. External systems provided unprecedented operational flexibility, innovative tactical options, essential emergency capabilities, and valuable logistical advantages that fundamentally transformed American effectiveness across multiple mission types and varied operational scenarios throughout the Pacific theater. Japanese military intelligence analysts studied American external tank effectiveness with rapidly growing alarm throughout the spring and summer months of 1945. Captured intelligence documents subsequently revealed detailed technical assessments of American technology prepared specifically for Imperial General Headquarters, staff personnel responsible for planning comprehensive home island defense, operations against anticipated Allied invasion attempts. Senior Japanese intelligence officers clearly recognized that American aircraft equipped with sophisticated external systems could now successfully escort heavy bomber formations to virtually any target located within the Japanese archipelago without requiring additional forward airbase construction or complex logistical support infrastructure that could be disrupted by Japanese defensive operations. Detailed intelligence estimates derived from captured American equipment and interrogated prisoner statements indicated that American aircraft possessed capacity substantially exceeding all previous Japanese intelligence assessments and technical evaluations. These reports acknowledged that extended-range escort capability had dramatically reduced American heavy bomber formation losses to operationally sustainable levels, enabling continued intensive strategic bombing operations against Japan's most critical industrial and military targets. Japanese intelligence specialists calculated that American heavy bomber formation losses had declined precipitously from over 15% of participating aircraft during unescorted missions to less than 3% when operating, with continuous escort protection. This dramatic casualty reduction fundamentally altered the strategic bombing campaign's cost-effectiveness ratio while enabling sustained operations that Japanese defensive forces could not prevent or significantly disrupt. Japanese military forces attempted developing various countermeasures designed to neutralize American external advantages, but severe technological limitations, critical industrial capacity constraints, and limited engineering experience with large-scale systems created apparently insurmountable obstacles to matching American technological achievements within available time constraints and resource limitations. Raw material shortages, particularly critical shortages of aluminum and specialized alloys, severely limited Japanese production capabilities. Manufacturing capacity constraints prevented mass production of systems even when adequate materials were available. Engineering inexperience with sophisticated integration created reliability and safety problems that significantly reduced operational effectiveness of Japanese systems compared to proven American designs and manufacturing standards. Japanese aircraft manufacturers made determined attempts to counter American external superiority through intensive indigenous technology development programs, utilizing available resources and manufacturing capabilities. The Nakajima Aircraft Company developed various system configurations for key 84 Frank aircraft, theoretically extending operational range to over 1,000 miles under optimal flight conditions and careful management procedures. However, Japanese manufactured containers consistently suffered from crude construction methods, fundamentally unreliable release mechanisms, persistent integration problems that American engineering teams had systematically solved through extensive development programs, and serious quality control issues that dramatically reduced operational reliability under actual combat conditions and extended flight operations. Production statistics starkly revealed the enormous magnitude of Japanese industrial disadvantages compared to American manufacturing capabilities. American industrial facilities successfully produced over 150,000 external tanks during 1945 alone, while Japanese manufacturers completed fewer than 5,000 systems of all types and configurations during the identical time period. Quality performance differences proved equally significant for operational effectiveness. American manufactured systems achieved over 95% operational reliability rates under combat conditions, while Japanese-produced systems experienced mechanical problem rates consistently exceeding 20% during actual combat operations, creating serious safety hazards and mission effectiveness problems. The Mitsubishi A7M SAM aircraft incorporated substantially increased internal capacity, specifically intended to match American long-range capabilities without requiring external systems, but the extensive design compromises necessary for achieving significantly extended range resulted in substantially reduced maximum speed, decreased maneuverability, and seriously compromised combat effectiveness characteristics compared to conventional aircraft designs optimized for air superiority missions. Japanese pilots generally preferred external solutions when reliable systems were available, recognizing the tactical advantages of being able to jettison external loads when combat situations demanded maximum aircraft performance. However, severe industrial capacity limitations and persistent quality control problems prevented large-scale mass production of reliable systems with performance and reliability characteristics comparable to American manufacturing, achievements and engineering standards. Japanese tactical military doctrine traditionally emphasized aggressive individual action over sophisticated technological solutions to operational problems, creating fundamental philosophical differences that seriously complicated effective responses to American technological innovations and industrial advantages. While Japanese manufacturers produced various configurations utilizing available materials and manufacturing techniques, senior military leadership continued, believing that superior individual pilot training and traditional fighting spirit remained more important than advanced technological advantages or sophisticated equipment systems. These deeply embedded cultural biases and traditional military attitudes prevented systematic development of technology programs with sufficient priority, funding, and technical resources to match American industrial and engineering capabilities within the limited time remaining before anticipated Allied invasion operations. Strategic resource allocation decisions consistently favored conventional aircraft production and traditional pilot training programs rather than innovative technologies requiring substantial research and development investments. Senior Japanese military officers, particularly those with extensive combat experience throughout the Pacific Theater, clearly recognized the critical strategic significance of American technological superiority in external systems, but lacked sufficient authority or influence to redirect major industrial priorities toward development programs that could potentially counter American advantages through alternative technological approaches. Japanese defensive forces discovered several limited methods for countering external tank advantages under specific tactical circumstances and operational conditions. At Okinawa, experienced radar operators learned to distinguish between American aircraft configurations carrying containers versus those configured specifically for air superiority combat missions without external systems. Tank-equipped aircraft displayed distinctly different flight characteristics and radar signatures during mission approach phases, enabling trained Japanese ground controllers to vector available interceptor aircraft toward the most tactically vulnerable targets during specific mission segments, when American pilots remained reluctant to jettison partially filled containers due to range requirements for successful mission completion and safe return to base. Japanese pilots developed specialized harassment tactics, specifically designed to force American escort aircraft to jettison external containers prematurely during critical mission approach phases. By initiating high-speed attacks while American escort formations remained hundreds of miles distant from assigned target areas, Japanese interceptor aircraft could compel American pilots to drop containers while still substantial distances from tactical objectives. This tactical approach occasionally succeeded in reducing American escort effectiveness by limiting aircraft loiter time over Japanese targets and sometimes forcing escort aircraft to return to base facilities before escorted bomber formations completed their assigned precision bombing missions against critical industrial or military targets. However, even the most successful Japanese countermeasures proved ultimately ineffective against the overwhelming American production capacity and operational flexibility provided by virtually unlimited container availability. For every Japanese tactical innovation or defensive measure, American military forces could deploy multiple tank-equipped squadrons that systematically overwhelmed Japanese defensive capabilities through superior numerical strength, technological advantages, and comprehensive training programs. when Japanese pilots occasionally succeeded in forcing premature container jettisoning during bomber formation approach phases, American mission planning staffs could simply assign additional squadrons to provide continuous escort coverage throughout complete mission profiles, ensuring adequate protection regardless of Japanese defensive tactics or consumption factors. The stark mathematical realities facing Japanese defensive forces were virtually insurmountable. Japanese operational strength had declined to fewer than 400 airworthy aircraft by May 1945, while American forces routinely deployed over 800 P-51 Mustang aircraft, equipped with external systems operating from Iwo Jima facilities alone. Additional American groups operating from Okinawa, other Pacific Theater bases, and aircraft carrier formations brought total American strength to over 2,000 operational aircraft capable of extended-range escort operations against any Japanese targets throughout the home islands. American external tank production reached truly extraordinary levels during the final months of active Pacific Theater warfare. The first 8 months of 1945 witnessed over 150,000 containers manufactured by American industrial facilities, nearly equaling combined production totals from all previous 3 years of wartime manufacturing. Republic Aviation Corporation, North American Aviation, and Consolidated Aircraft Corporation maintained continuous production operations with multiple shifts operating 24 hours daily to meet expanding military requirements across European, Mediterranean, and Pacific theaters simultaneously. Manufacturing efficiency improvements achieved during intensive wartime production created remarkable unit cost reductions, while simultaneously achieving substantial quality enhancements compared to early experimental systems. Initial prototype containers cost over $500 each to manufacture under laboratory conditions, but advanced mass production techniques successfully reduced individual unit costs to under $50, while dramatically improving reliability and operational performance characteristics. These significant cost improvements enabled widespread deployment of systems across all American units, regardless of theater assignment, mission requirements, or logistical constraints. Economic efficiency, combined with superior performance, created decisive strategic advantages that enemy forces could not match through conventional defensive measures or alternative tactical approaches. Container manufacturing represented far more than impressive industrial achievement, SA. It successfully embodied American technological superiority, systematically translated into decisive strategic advantages across all active theaters of military operation. Early experimental designs developed at Selfridge Field had provided crucial conceptual foundations and basic engineering principles, but American industrial engineers and manufacturing specialists had successfully transformed experimental technology into sophisticated mass-produced systems capable of equipping every squadron in United States military service, worldwide. Comprehensive quality control procedures ensured consistent performance standards under the most extreme operational conditions imaginable. Each individual tank underwent rigorous pressure testing, leak detection procedures, and mounting system evaluation protocols before delivery to operational military units. Precision system components required exact manufacturing tolerances, preventing contamination or flow disruption that could cause catastrophic engine problems during critical combat operations over hostile territory. Release mechanism systems endured extensive vibration testing, simulating thousands of hours under combat conditions, ensuring absolutely reliable separation when activated under extreme combat stress and high-G maneuvering loads that could exceed normal human physiological endurance. These comprehensive testing procedures guaranteed operational reliability under conditions substantially exceeding normal peacetime aviation operational requirements. This unprecedented production surge created comprehensive strategic implications, extending far beyond individual combat mission effectiveness or tactical applications in specific theater operations. Japanese military forces now confronted American aircraft capable of successfully escorting heavy bomber formations to any target located within a 1,000-mile operational radius of American airbase facilities throughout the Pacific Theater region. Every significant Japanese airfield, major industrial facility, critical military installation, and important urban center throughout the home islands lay within effective range of escorted precision bombing attacks, fundamentally altering strategic balance throughout the Pacific War's final operational phase. Japanese defensive planning concepts based on geographical isolation and limited Allied aircraft range had become completely obsolete due to American technological and industrial achievements. Industrial capacity comparisons between American and Japanese manufacturing capabilities revealed the enormous magnitude of Allied material advantages that Japanese forces could never hope to overcome through conventional military means. United States aircraft manufacturing facilities produced over 40,000 aircraft during 1945, while Japanese industrial facilities completed fewer than 8,000 aircraft of all types and configurations. Combined, American container production alone exceeded total Japanese production figures by mathematical factors exceeding 20 to 1, reflecting not only superior industrial manufacturing capacity, but also advanced technological sophistication, abundant raw material availability, and systematic approaches to wartime production organization that Japanese military industries could never match under wartime conditions with limited resources and constant Allied bombing pressure. Tactical operational flexibility provided by external systems completely revolutionized American air operations, planning procedures throughout the Pacific Theater command structure and strategic planning organization. Unit commanders could now deploy escort formations anywhere within their extended operational radius without requesting special permission from higher military headquarters or coordinating complex logistical support arrangements that could delay time-sensitive combat operations. Mission planning staffs gained capability to adjust escort coverage assignments in real time based on rapidly changing tactical intelligence information and evolving weather conditions affecting mission success probabilities. Squadrons could coordinate multiple simultaneous combat missions, supporting complex operational objectives across vast geographic areas, previously considered completely beyond single-engine aircraft capabilities under circumstances. Strategic bombing campaign effectiveness increased dramatically, following systematic introduction of extended-range escort operations throughout the Pacific Theater. Heavy bomber formations operating with continuous protection consistently achieved target destruction rates, exceeding 80% of assigned objectives compared to less than 40% success rates for unescorted bombing missions, against heavily defended Japanese industrial and military targets. Japanese industrial manufacturing capacity, already severely strained by critical raw material shortages and devastating Allied submarine warfare campaigns against supply shipping, could not sustain production levels necessary for continuing effective military resistance. Under sustained precision bombing attacks protected by superior American escorts operating with virtual impunity over Japanese territory. Japanese military commanders operating under traditionally rigid command structures and severely limited communications capabilities could not match American operational responsiveness enabled by external technology and flexible tactical doctrine development. By the time Japanese officers could coordinate defensive responses through traditional military command channels and cumbersome decision-making processes, American formations had typically completed their assigned combat missions and returned safely to base facilities with minimal losses. Advanced technological advantages provided American forces with tactical flexibility that Japanese military organizations could not effectively counter through conventional organizational modifications or alternative doctrinal approaches. Alone. Communication system disparities compounded Japanese defensive coordination problems throughout the home island's defense operations. American formations maintained reliable tactical coordination through sophisticated radio communication systems, while Japanese defensive units often relied on primitive visual signaling methods or predetermined tactical plans that could not adapt effectively to rapidly changing combat situations and unexpected tactical developments during actual engagement operations. This comprehensive communications disparity, combined with decisive American technological superiority in aircraft performance and external systems, created virtually insurmountable tactical disadvantages for Japanese defensive forces throughout the home islands region during the final months of Pacific Theater combat operations. American technological superiority became increasingly apparent as Allied military forces advanced systematically across Pacific Island chains toward Japan itself during the final months of active warfare. On Iwo Jima, during February and March operations, Japanese defenders had constructed elaborate underground defensive systems specifically designed to neutralize traditional American advantages in artillery power and armored mobility through carefully prepared defensive positions and extensive tunnel networks connecting fortified combat positions. Lieutenant General Tadamichi Kuribayashi commanded 21,000 experienced Japanese troops armed with extensive artillery systems, mortars, and machine guns positioned in heavily fortified defensive positions covering every conceivable landing area around the island perimeter. These defensive preparations represented the most sophisticated and comprehensive fortification system constructed by Japanese forces throughout the Pacific Theater campaign. Yet American capture of Iwo Jima's strategic airfield facilities enabled immediate deployment of container-equipped P-51 Mustang aircraft within practical escort range of Japan itself for the first time during the Pacific Theater campaign. The enormous strategic value of this costly volcanic island was not its defensive potential or symbolic importance for Japanese morale, but its practical utility as an advanced base for extended-range combat operations against the Japanese homeland itself. Geographic positioning proved absolutely crucial for American strategic planning. Iwo Jima's location placed advanced P-51 Mustang aircraft within 675 miles of Tokyo, representing theoretical maximum operational range using internal capacity alone but practical. Combat operational range, when aircraft were properly equipped with external containers, providing necessary safety margins for combat operations and return flights under adverse weather conditions or unexpected combat circumstances. This optimal positioning completely eliminated traditional Japanese defensive advantages based on interior defensive lines and limited Allied aircraft range restrictions that had constrained previous American bombing operations against Japanese industrial and military targets throughout the home islands region. As the Pacific Theater War approached its inevitable conclusion during summer 1945, American military leadership clearly recognized that external tank technology had fundamentally and permanently altered aerial warfare doctrine and strategic planning concepts. The demonstrated capability of extending single-engine aircraft range far beyond previous physical limitations enabled comprehensive strategic bombing campaigns that Japanese air defense forces could not effectively counter through any conventional defensive measures or tactical innovations. Revolutionary container concepts would continue influencing and transforming military aviation development through the Korean War conflict, Vietnam War operations, and into modern aerospace technology utilizing advanced management systems, aerial refueling capabilities, and sophisticated range extension technologies that continue evolving today. North American P-51 Mustang aircraft equipped with external systems had conclusively proven their remarkable effectiveness across every conceivable combat scenario throughout the Pacific Theater: extended range, escort missions, sweep operations, ground attack missions, reconnaissance flights, combat rescue operations, and tactical support missions covering vast oceanic distances previously considered impossible for single-engine military aircraft. Continuous technological advancement never ceased throughout the war period, and substantially improved system designs were already systematically replacing wartime production systems before Japanese surrender ceremonies concluded active hostilities. Advanced storage concepts would eventually evolve into modern conformal tank systems, sophisticated aerial refueling technologies, and advanced management systems that continue advancing through contemporary aerospace engineering development programs. The comprehensive strategic impact of external technology extended substantially beyond immediate military applications and combat effectiveness measurements. Container development demonstrated American industrial capacity for systematic innovation, mass production efficiency, and quality control standards that impressed Allied nations, while simultaneously discouraging potential adversaries from considering military confrontation with American technological and industrial capabilities. Post-war military strategic planning incorporated essential lessons learned from external operations throughout the Pacific Theater, consistently emphasizing technological superiority and advanced industrial capacity as fundamental foundations for national defense strategy during the emerging Cold War period and subsequent international security challenges. External tanks achieved something truly remarkable, extending far beyond their immediate technical specifications and direct combat applications alone. American aviation experiments, beginning with primitive systems tested at Selfridge Field and systematically developed through comprehensive wartime industrial capacity, had successfully created sophisticated systems enabling single-engine aircraft to escort heavy bomber formations across distances previously considered completely impossible under existing technological constraints and operational limitations. Japanese military forces, despite demonstrating exceptional individual courage, proven tactical skill, and extensive combat experience accumulated throughout years of intensive warfare across the Pacific Theater, simply could not match American military units equipped with revolutionary technology that effectively doubled or tripled practical operational range capabilities while maintaining superior combat effectiveness. The comprehensive container revolution clearly demonstrates how systematic technological innovation, unprecedented industrial manufacturing capacity, and flexible tactical doctrine development combined to create decisive battlefield superiority that transcended individual combat effectiveness, measurements, or specific technological specifications. Japanese pilots, despite intensive training programs and extensive combat experience accumulated over years of continuous warfare, confronted American formations possessing operational capabilities that Japanese military planners had previously considered technically impossible under any existing technological and industrial constraints. When Captain Robert Phillips jettisoned his external tanks over Tokyo during that historic April morning in 1945, he was successfully utilizing advanced American concepts developed from original Selfridge Field experiments in ways that original designers and engineers had never imagined possible during initial development phases. When Technical Sergeant Michael Kowalski successfully used emergency transfer procedures to save his severely damaged aircraft during extended combat operations over hostile territory, he was applying proven tactical principles that had revolutionized operations across all global theaters of active warfare. When Lieutenant Colonel James Tapp ordered his complete squadron to drop partially filled containers directly onto attacking Japanese formations below, he was successfully demonstrating how superior American technology enabled innovative tactical applications that conventional military doctrine had never anticipated or prepared for, effectively through traditional training programs and tactical development procedures. The shocked Japanese pilots encountering long-range American escort aircraft operating over their defended homeland territory confronted far more than individual enemy aircraft equipped with superior performance characteristics, too. They faced the concentrated industrial power of 150,000 precision-manufactured containers supported by the world's most advanced production systems, comprehensive quality control procedures, and systematic technological innovation capabilities that no other nation could match. Quick-release mechanisms enabling virtually instantaneous tank jettisoning represented far more than clever engineering solutions to technical problems. They successfully embodied fundamental American approaches to military operations, emphasizing decisive technological superiority, unprecedented operational flexibility, and overwhelming material advantages that traditional military thinking and conventional tactical doctrine could neither match nor effectively counter. Japanese military forces, fighting with conventional tactics and severely limited industrial support capabilities, discovered that individual determination and tactical skill alone could never overcome enemies equipped with sophisticated pace systems delivering unprecedented operational range capabilities backed by systematic industrial production capacity that exceeded Japanese manufacturing by mathematical factors exceeding 20 to 1. External tanks, enabling American aircraft to appear over Tokyo, represented the complete triumph of systematic technological innovation over traditional military limitations, advanced industrial democracy over resource-constrained authoritarian systems, and comprehensive engineering solutions over individual heroism and fighting spirit that could not compensate for fundamental technological and industrial disadvantages. From Selfridge Field's muddy experimental programs through Detroit's rapidly expanding wartime production facilities to the volcanic airfields of Iwo Jima, external tank technology successfully connected American innovation with unprecedented manufacturing capacity to achieve decisive strategic victory throughout the Pacific Theater. American pilots calling their containers range extenders were not simply describing specialized equipment attached to their aircraft. They were accurately describing a complete technological revolution that had fundamentally transformed single-engine aircraft from short-range interceptors into long-range escort machines capable of protecting bomber formations anywhere within a 1,000-mile operational radius. Japanese pilots facing extended-range American escorts at Tokyo, Osaka, Nagoya, and Yokohama fought using conventional tactics against enemies who had fundamentally changed the basic relationships between aircraft operational range, combat effectiveness, and strategic capability throughout modern aerial warfare. When the final container-equipped P-51 Mustang landed at Iwo Jima on August 14, 1945, it marked not just the Pacific Theater campaign's successful conclusion, but the definitive end of a historical era when geographical distance could provide meaningful protection from enemy aircraft equipped with advanced range extension capabilities. American innovation had successfully enabled squadrons to escort bomber formations across previously prohibitive distances, provide continuous protective coverage during extended combat missions lasting up to 8 hours, and maintain decisive air superiority over enemy territory located hundreds of miles from friendly base facilities. The revolutionary range extenders that had shocked Japanese air commanders throughout the Pacific Theater represented far more than superior storage technology. They represented the complete triumph of systematic innovation over traditional limitations, advanced industrial capacity over resource constraints, and technological flexibility over conventional tactical thinking that permanently altered fundamental principles of modern warfare and strategic planning assumptions for generations to come.